Can we find exoplanets similar to Earth? Oceans, trees, forests, perhaps even some kind of humanoid alien life? What would this planet look like? It might be smaller than Earth, or it could be larger. Astronomers are currently searching for such planets, but discovering them isn't easy. With the help of existing technology, we can discover many massive planets, but finding Earth-sized planets is much more challenging. Of course, there are exceptions. The first Earth-like planet discovered was KEPLER 22b. It was detected in 2009. Now, we know that this amazing planet is located within the habitable zone of its host star. But what is the habitable zone? What are the main characteristics of KEPLER 22b? Is there a possibility of life on this planet? Let's find out. How do astronomers find exoplanets? Firstly, how do astronomers find exoplanets? There are various technologies, but the most commonly used are direct imaging, radial velocity method, and transit method. So far, we know that different technologies are more sensitive to different kinds of planets. But for example, direct imaging. By using large telescopes equipped with adaptive optics, direct imaging of exoplanets improves their performance. This technology is more sensitive to planets that are higher in temperature, younger in age, more massive, and have highly eccentric orbits. In fact, the more elongated the orbit, the larger the angle it creates in the sky, making it easier to detect. The radial velocity method utilizes the well-known Doppler effect. Astronomers use spectrographs to obtain the spectrum of the host star because stars and planets are gravitationally bound, causing them to orbit around a common center of mass. This means that during their orbit, the star will move back and forth. This wobbling motion shows up in the spectrogram as Doppler shifts. This method is very sensitive to massive planets with orbits that are inclined relative to our line of sight, closer to their host stars, since these massive planets exert a greater gravitational pull on their host stars, causing more significant stellar wobbles. The transit method, which is the most common and effective, is essentially a game of shadows. Exoplanets are detected by measuring the periodic drop in brightness of a star as a planet crosses in front of it. Imagine watching a star, and at a specific time, a planet happens to pass across its disk. What you would see is a small eclipse, where the star's brightness decreases as the planet moves in front of it. This technique is sensitive to large exoplanets orbiting close to their host stars. KEPLER 22b, a special exoplanet. For instance, KEPLER 22b was discovered using the transit method. The telescope used for this study is the famous Kepler Space Telescope, a powerful tool for finding exoplanets. Kepler telescope detects planets and candidate planets by measuring the brightness changes of over 150,000 stars to look for planets crossing in front of their stars. It requires at least 3 transits to verify if the signal is indeed from a planet. What makes KEPLER 22b so special? It was the first planet confirmed to be in the habitable zone of a star similar to the Sun. This region is defined as the orbital area around a star where a planet's surface could support liquid water and possibly life. Liquid water is essential for all known life on Earth, so the definition of a habitable zone is based on the assumption that extraterrestrial life would also require liquid water. Of course, as we know, having liquid water on the surface of a planet alone is not enough for life to exist. Further research is needed, but at least it is a necessary condition. So what do we know about this possible Earth-like planet? We know it is 600 light-years away from Earth. Although this planet is larger than Earth, it orbits a star similar to our Sun with a 290-day orbital period, quite similar to our beautiful world. The host star of this planet belongs to the same class as our Sun, known as a G-type star, although it is slightly smaller and cooler. KEPLER 22b receives about 25% less light from its star compared to what Earth gets from the Sun. We also know that KEPLER 22b is the smallest planet discovered so far with an orbit in the habitable zone of a star similar to the Sun. To give you some numbers, its radius is 2.4 times that of Earth. Scientists still don't know whether KEPLER 22b's main components are rock, gas, or liquid, but its discovery has sparked a wave of interest in finding Earth-like planets. Discovering Earth-sized or smaller planets is no easy task. In fact, as we mentioned earlier, most modern techniques are not capable of finding large, massive planets with highly eccentric orbits. But sometimes scientists get lucky. For example, other small planets orbiting smaller, cooler stars than the Sun have recently been found on the edge of the habitable zone. Their orbits are closer to those of Venus and Mars. According to William Barucki, the principal investigator of the Kepler mission at NASA's Ames Research Center, finding this planet was a stroke of luck. We captured the first transit within 3 days after the spacecraft became operational. We observed the decisive third transit during the holiday season in 2010. To understand what we're looking at, take a look at this diagram. The x-axis represents the semi-major axis of the planet's orbit, i.e., the distance of the planet from its host star. As we move right from the origin, it increases. The y-axis represents the planet's mass, which increases upwards. These shapes represent various detection techniques. As you can see, if they are very close to their host star, the transit method and radial velocity method are, to date, the most helpful techniques for finding smaller mass planets. The black triangles indicate the so-called immediate technology, but we need a team to use this technology to provide more data. NASA's Kepler mission website estimates that this planet's mass is between 36 to 124 times that of Earth. Considering the possible mass range between 6.36 Earth masses and 124 Earth masses, it is easy to get the possible surface gravity interval, ranging from the most likely 1.1 g to an overestimated 21.5 g. However, using the only data we have, if the planet is composed of the same elements as Earth with the same distribution ratio, then its mass would be 13.8 Earth masses, and the surface gravity would be 2.4 g. But we know that the volume of this planet is 2.4 times that of Earth, which might tell us that Kepler 22B's composition is different from Earth. Some astrophysicists say it might be an ocean planet. But what does that mean exactly? Ocean planets are planets made up of rocky cores surrounded by vast amounts of ice and water. On the surface, there is a vast ocean. Can you imagine? If you were to live on Kepler 22B, you would have to swim frequently. However, it's also possible that its outer layer contains abundant volatile elements, which would make this planet a gas dwarf. Kepler 22B is very close to its host star, much closer than Earth is to the Sun. However, the luminosity of its star is lower than that of the Sun. Combining these two parameters, we can say that the surface temperature of this planet is moderate. As we know, this is an ideal condition for the existence of life. Of course, everything depends on the atmosphere. Without it, the planet would be very cold, around 11 degrees C. But if the atmosphere exists, the greenhouse effect would be similar to Earth, making the average temperature about 22 degrees C. The Kepler team uses ground-based telescopes and the space-based telescope to review the candidate planets discovered by the spacecraft. The stars observed by the Kepler telescope in the Cygnus and Lyra constellations can only be seen from ground-based observatories from spring to early autumn. Data from other observations help determine which candidates can be confirmed as planets. As far as we know, Kepler 22B is not the only planet found in the habitable zone so far. Kepler has also discovered over 1,000 newly confirmed exoplanets, almost double the previously known number. Among these candidate planets, many are similar in size to Earth and have orbits within the habitable zones of their host stars. Candidate planets require follow-up observations to confirm they are genuine planets. Of the 1,780 confirmed exoplanets outside the solar system, up to 16 are located in their star's habitable zone, where conditions are not too hot or too cold for life. For example, if a planet's orbit is too close to its sun, surface water would evaporate into space, making the planet too hot to meet habitable zone conditions. On the other side, a planet could be too cold, which is the case for planets orbiting far from their host stars. In this region, any surface water would remain frozen. Size also matters. Planets that are too small cannot maintain an atmosphere, while those that are too large would have a crushing atmosphere. A recently discovered planet, Kepler 186f, located 493 light-years from Earth, is almost Earth-sized and lies within the habitable zone of its star. So far, most confirmed exoplanets are much larger and hotter than Earth, making them easier to detect but less interesting in the search for life. Unfortunately, most planets found in the habitable zone ultimately turn out to be uninhabitable, as follow-up research reveals conditions that do not support life. For example, one of the most promising planets, Gliese 581c, the first super-Earth discovered in the habitable zone, was later found to have extreme surface conditions, possibly similar to Venus. So, conclusion. What do you think of Kepler 22B? Please let us know in the comments below. I'm very curious about what it would be like if we could actually visit these planets similar to our home, if we already had enough technology to create colonies there. Humanity taking root on another planet. I know it's a little repetitive on movie screens, but I never get tired of thinking about things like that. I really believe that a series on Netflix would be very successful about Kepler 22B. So if you like this video, don't forget to share it. See you next time.